All right, guys. Good evening. So we are about to commence the class. Okay, so we're about to start. But it's important to note that your examination is tomorrow, and as such, we are going to be going straight to what you'll be expecting. For instance, while I'm going to be treating 2022, 2023, same coordinator is the one setting the question, so the exam will not be too different or too far away from what you are going to be seeing tomorrow. And then when I use that particular past question you know, to teach you guys, it's just that I'm just trying to cut across all the questions as far as the course is concerned. So, okay. So now I want you to understand this. In in our 1 o'clock class, we looked at the limit of a function. We looked at okay, we wanted to see how to differentiate functions, and then we also look at the applications. So we just pick few questions to help us scale through. All right. So from the past question here, please, we are going to, okay, there was a function we were supposed to differentiate before we wait for break. Let's say I have that, let's solve this question, that y is equals to 1 over ax plus 1 raised to the power of 3. That is a past question which has to do with differentiation. So the question is, how do we differentiate this? Please note that I illustrated something that if I have a raised to the power minus n, that is the same thing as 1 over a raised to the power n, meaning that I can write this back in this form as pick the denominator a raised to the power of n, and 1 over is this small minus, so you put it in between. So you have been able to write it from this to this. So that's exactly what we are going to do to get this place simply. I mean, to rewrite this. So we are going to have this to be y equals to, don't forget, whenever you are differentiating, it is always in power form. So this is going to be, pick the denominator, which is a raised to the power ax plus 1 raised to the power of 3. That's the denominator. Then this 1 over is this minus here. Okay. So at this point, we have been able to write it in a differentiable form, and this is talking about chain function. So you use chain rule to differentiate this. How do you differentiate? You are going to say that dy over dx is equals to, please note that if I have y is equals to 2x plus 3 raised to the power of 4, that dy over dx is equals to, this is chain function. How do you differentiate it? Using the shortcut. Step 1, bring down this 4. Look at it. Step 2, differentiate the bracket. So what's the derivative of 2x? If you differentiate x, you have 1. 1 times 2 is 2. Then if you differentiate 3, you have 0. So the derivative of 2x plus 3 is simply 2. Look at that 2 here. Step 3, repeat the entire bracket, 2x plus 3. Step 4, Subtract 1 from the power. So raised to the power 4 minus 1 will give you 3. So that means that dy over dx is equals to 4 times 2 is 8 into 2x plus 3 raised to the power of 3. That is how to differentiate and a chain function using the shortcuts. Okay. Okay. Okay, so that's exactly what we are going to use to differentiate this. All right, let's go. So exactly what we are going to do here. Step 1, bring down the power. What's the power? Minus 3. So I'll bring down minus 3. Step 2, differentiate what you have inside the bracket. That is, if you differentiate ax, you are going to have a, if you differentiate x, you have 1. 1 times a is a. Differentiate 1, you have 0. So that means that the derivative of ax plus 1 is simply a. So look at it here, a. Step 3, repeat the bracket, which is ax plus 1. Step 4, subtract 1 from the power. So that is minus 3 minus 1. Definitely, minus 3 minus 1 will give you minus 4. So it means that dy over dx is equals to minus 3a times this small minus here is 1 over. Then you are left with ax plus 1 raised to the power of 4. You bring it down. Ax plus 1 raised to the power of 4. So I brought it down. It means that dy over dx is equals to minus 3a times 1 will give you minus 3a all over ax plus 1 raised to the power of 4. All over ax plus 1 raised to the power of 4. So that gives you the answer to that. So that is, let me read out the options. Okay. Remember, we're dealing with 2022, 2023. So that is option B, minus 3a all over ax plus 1 raised to the power of 4. That is option B. So, guys, please remember to share the link to your classmates to join the live class, okay? So that's how to differentiate chain function, or what you call function of a function. Now, let me also bring up a question that will teach us how to differentiate another type of function, maybe implicit function and also parametric function. So we'll take one from parametric, we take one from implicit. Okay. So I'm going to pick one. Okay, this one says evaluate dy dx if x is equals to t plus cos t and y is equals to t plus sin t. Okay, that's automatically an example of a type of function that is called parametric function. Parametric function. So, this is x being equals to t plus cos t and y is equals to t plus sin t. Are we together? Okay, so this x is a function of t and y is a function of t. So there's an introduction of a third variable. Remember, we always have x and y. So there's the introduction of the third variable here, which is t, and this t here is called the parameter. All right. The question now is, how do we differentiate parametric function? Is very simple. So what do we do? Let's go. X is equals to solution. X is equals to t plus cos t. T plus cos t. So dx dt, the x over dt will be equals to, what is the derivative of t? Don't forget that if you differentiate x, you have 1. So anytime you differentiate a variable, you must have 1. So the derivative of t is 1. Look at it, 1 plus, what's the derivative of cos t? Don't forget that if y is equals to sine t, dy over dt will be equals to cos t. Then if you differentiate cos t, that is, if y is equals to cos t, dy over the x dt rather will be equals to minus sine t. So if you differentiate sine t, you get positive cos t. If you differentiate cos t, you get negative sine t. So the derivative of cos t is minus sine t, meaning that dy, sorry, dx dt is equals to 1. Plus minus is minus. So 1 minus sine t. You are done differentiating that. Next, you pick the next function there, which is y being equals to t plus sine t, meaning that dy over dt will be equals to dy dt will be, what's the derivative of t? 1. So you have 1 plus, what's the derivative of sine t? Cos t. So you have cos t is, I need to check if the network okay. So it means that dy over dx is, so after differentiating, the next thing you should now know that dy dx will be equals to this. The formula is dy over dt divided by dx over dt. If that is true, let's confirm. That is a dy dt times dt over dx. This and this will go, so dy dx. Okay, that means that this formula is very correct. So now this is going to be equals to, what is dy dt? Dy dt is 1 plus cos t. So you have 1 plus cos t all over, what is dx dt? Dx dt is 1 minus sine t all over 1 minus sine t. So that's exactly how to get that done. And let's check which option is that. 1 plus cos t all over 1 minus sine t. That's option A in the options here. So that's exactly how to differentiate parametric function. Now let's pick an example of an implicit function and see how we can differentiate that. You say we cannot. Are you serious? That person is using pop 2. Okay. Please be checking the comments for me. I don't know. So now we are going to pick an example, a question from implicit function. So let's say we have a function, say x, if x cos y plus y is equals to 4x. Find the y dx. So this is an example of an implicit function. So in this particular function, we are to find dy dx. And of course, the options are here, which I'll let you know the correct option at the end of the solution. So this is very, very important. Now the question is, how do we differentiate implicit function using the shortcuts? The shortcut. Step one, you take everything to the left hand side and equate it to 0. So that means that this is going to be x cos y plus y. 4x will move to the left and become minus 4x equals to 0. Equals to 0. So that's the first step. And then for us to differentiate this implicitly, we are going to use a shortcut, and that is just to remember a formula that dy over dx is equals to minus partial x over partial y. That is to say, we are going to differentiate it partially with respect to x and partially with respect to y. That's a shortcut we are going to be using. All right, what do we mean? It's very simple. So that means that dy over dx will be equals to minus into. Okay, let's differentiate now with respect to x. Differentiating with respect to x implies that if if I am differentiating any term without x, means it tends to 0. That's to say it is a dummy variable. Is 0. Okay, let's go straight to the point. How do we differentiate? Let's differentiate this now. Remember, I'm differentiating with respect to x. So look at x here. What's the derivative of x? 1. Now, 1 times cos x is what? Cos x. That's why we get cos x. All right, let's look at the next term. Do we have x there? Don't forget we are differentiating with respect to what? X. Do we have x here? No. Automatically, this one is 0. Since there is no x there, it is 0. We move on to the next one. This is, do we have x here? Yes. So what's the derivative of x? 1. 1 times minus 4 is what? Minus 4. So we are done with that. All over. We are now going to differentiate partially with respect to what? Y. Now, question, does this have y? Does this have y? Yes. Look at cos y now, isn't it? So what's the derivative of cos y? Minus sin y. The derivative of cos y is minus sin y. Minus sin y times x is what? Minus x sin y. Minus x sin y. Okay. Now, does this have y? Yes. What's the derivative of y? 1. So that will be plus 1. Does this one have y? No. So that means it is what? 0. Good. So we're done with differentiating that. That will now mean that dy over the x will be equals to, okay? Use this negative sign here to open a bracket at the numerator. So minus times cos x is what? Minus cos x. Minus times minus 4 plus 4 all over minus x sin y plus 1. This minus is only for, it doesn't affect this. Are we there? Okay. So that means that dy over the x is equals to, I can write, positive 4 first before I write negative cos x. So that will be 4 minus cos x. 4 plus 4 minus cos x all over 1 minus x sin y. 1 minus x sin y. That becomes the answer. So that is option 4 minus cos y all over 1. That's option C. it is option C in this particular um, option. That's option C. All right. So we have seen an example of how to differentiate parametric function. We have also seen an example of how to differentiate implicit function. Now, there are a lot of functions we are going to be differentiating as we keep going. Then, after that, we'll also look at how to find domain and range of root functions and stuffs like that. But before then, let's move to certain applications of differentiation. All right, we have application to normal and tangent to curve. We also have application to okay, we have application to normal and tangent to curve, velocity, acceleration, um, extrema of functions, and stationary points and stuffs like that. So, okay, okay, I'm just reading some comments. Someone is saying, please, I can't see the board, but the board is big. You can see. It's clear. It's please go and say your pop too. Because I can't see the board clearly too. That's the same thing. Pop two. Sell it and buy good phone. uh I can't see anything. Please do something about it. I beg. Sell your pop two. Okay, it's clear now. It's clear now. Okay, someone said I should drop location. Uruekwa. I still can't see. Please receive your site. Sorry. Receive your site. Please try your best. I don't know. The screen is big enough. You can see. And please, if you are not subscribed to my channel, don't forget to subscribe to my YouTube channel. Okay, let's look at application. Okay, let's pick an example. The question says, find the gradient of the normal to the curve. Find the gradient of the normal. Find the gradient of the normal to the curve. 4x cubed minus 4xy plus y squared is equals to 0 at 1 comma 2. Okay, the options are option A 2, option B minus 1 over 2, option C minus 2, option D 1 over 2. Please, you want to now, I'm telling you the facts. These are the areas you are definitely going to see problems on as far as exams tomorrow is concerned. These are the areas you are going to solve problems from. Definitely you must study something about tangent and normal, to equation of tangent, equation of normal, and how to find the gradient of normal. It's very important. So the question says, find the gradient of the normal. Don't forget that the gradient of tangent is m, but the gradient of normal is minus 1 over m, minus 1 over m. So this is very important. That means that if I'm looking for gradient of normal, it is the negative of 1 over the gradient of tangent, where this is the m1 is a, tangent. So take notes. The question says we should find the gradient of normal. So this is the formula we will need to get the gradient of normal. It's very, very important. Okay. So the question says find the gradient of normal to the curve this. Gradient of normal, the gradient of normal m2, the gradient of normal is given as m2. It is equals to minus 1 over m1, where m1 is a gradient of tangent.